Hello students, welcome to Basic Education, Mathematics, May, June, P2 2024. The total marks of this paper is 150 and the time limitation for this paper is 3 hours, okay? So let's start this paper. We have a question 1. So the question 1 is we have the number of pages in 10 A4 books and their corresponding weights in grams are given in the below table below. Okay, so the data is also represented in the scattered plot, as you can see over there. Over here the data is represented. We have the number of pages X and weight in grams is Y, and we have started from 85 to 160 is the number of pages, and weight in grams is 165 to 340, and this is the scattered plot. Okay, so the first question is of question number 1 is 1.1. Determine the equation of the least square regression line. Okay, so let's do this question number 1. Okay. So the journal form of the equation is y equals to a plus bx. Okay, as you know about that, the journal equation, journal form. Journal form. We have a y equals to a plus b x. Okay, so we have to put the formula to find the y-intercept. Okay, to find y-intercept, that is we have a. Okay, and we have the gradient that we call this is b. Okay, so when you do the calculator output, we're using the calculator to find, we have the a is equals to minus 43.72, and b we have 236. Okay, so we have to make, just write the equation, that is we have y equals to minus 43.72 plus 236x, and this is the required equation that we need to find out. Okay, the next question is 1.2. Draw the least square regression line on the scattered plot in the answer book. Okay, so we just need to redraw the graph. Okay, as you can see over there, we have this graph, the scattered graph that given in the questions, and you need to draw the straight line, and you need to that it touches these points. We have these points. Okay, these are points are out of the from the straight line. Okay, we just need to draw the graph. Okay, like we have the point 1, and where we have x is 100, as you can see over there. This is the point 1 where x is 100 and the y we have is 200. Okay, so we need to draw these points, point 1 and point 2, that exactly match over there. Like you can see that the point 2 is 140. All right, so the next question is 1.3. Predict the weight of an A4 book that has 110 pages. Okay, 110 pages. Like we have the pages between 100 to 120. This, okay? So we are using our line of the best fit to predict the weight y when the number of pages is 110. So this is the prediction or estimation, okay? So substitute for the value of x in equation that we have to make. What is the equation that we have to make is y equals to minus 4372 plus 236x. Okay, and then we have to substitute the value of x, which is 110, and now I'm putting the value in this question. So we get minus 4372 plus 236, and the value of x is 110. Okay, so after doing the simplification of this equation, we got 4372 plus 259 and 60, and we got y equals to 215.88 grams. Okay, this is the required answer that we have to predict the weight of an A4 book that has 110 pages. All right. Now, the next question is 1.4. Calculate the percentage weight increases between a book with 110 pages and a book with 130 pages. All right, so we have to calculate the percentage that is increases, okay? So we have the percentage increases, that is we have equals to the new value minus original value, okay, and then divided by whole with original value, okay, and multiply with this 100. All right, so I'm just putting the values. The new value we got is 263.08 and minus 215.88 divided by 215.88, okay? And the whole thing is multiply with 100 because we need to find out its percentage. So after solving this, we get a 47.20 by 2,588 multiply by 100, and when I'm solving this we get approximately 21.686 percentage. Okay, so we say that the percentage increases is this is the required answer that we need to find out. Okay, now the question number 2 is that 50 athletes needs to assess suitable training facilities. The table below shows the distance in kilometers that they need to travel to obtain access to suitable training facilities. So these are the distance we have in the table and number of athletes we have. So the question number 2.1 is that complete the cumulative frequency column provide in the table and in the answer book. Okay, so we have to find out the cumulative frequency, all right? So I'm just taking this this table again, and we need to copy that table and then we need to add a one more column over there, okay? All right. So I'm just making another column over here that we call this is cumulative frequency. Okay? So as you can see over there, we have number of athletes. Okay? So we have an 3. So I'm saying that the number of frequency, as you know about that, we write it 3. Now I'm taking this 3 plus this 7, we got 10. Okay, I'm taking this 10 plus this 20, that is equals to 30, and this 30 plus to this 12, we got 42, and this 42 add with this 5, we got 47, and this 47 we got added to in this 3, and we have a 50. Okay, so all the values must be correct for all the cumulative frequency. All right, so we have to record it at the upper limit of each interval. This is the required thing that we have to find out in this question. All right. So the next question is about 2.2. Okay. All right. On the grid provided, okay, we have to draw the cumulative frequency Augive graph. All right. So we plot the cumulative frequency against the upper class boundary of each interval starting at 0, 0 and ending at 30, 50. Ensure the curve is smooth. Okay. So for the plotting plot points, we have um, so the plot points we have is 0, 0, and we have in a 5, 3, 10, 10, 15 and 30, and 20 or a 42, and we have 25 and 47, and the last one is 30 and 50. Okay, so the graph is plotted with a smooth increasing curve that is be shown like that. Okay, this is how we draw the graph. We have this point 0, 0, 5 and 5, 15. This is the next point 10 and 10. We have this point 30 and 15. Okay, these are the points we have to show in this Augive graph. Okay, so the next is 2.3. Calculate the interquartile range IQR of the above data. Okay, so we estimate the quartiles Q1 and Q3 for the Augive. All right, so Q1 is at n by 4 is equals to 12. Okay, we consider that Q1 is at n by 4, that is equals to 12.5, and we have a Q3 that is at 3n by 4 is equals to 30. 0.5. Okay, so we need to find out IQR. So we have to find out the lower quartile, we have to find out the upper quartile, and then we have to subtract the upper from lower. Okay, so first of all, we have to find out the lower quartile. Okay, that is, we call this is Q1. All right, so we have an CF that is equals to 12.5. Okay, so read the distance from the graph. All right, so Q1 equals to, we have 11 kilometer. Okay, and acceptance between 10 to 12. Okay, this is between 10 to 12.5. All right, so the upper quartile we have, that is, we see that Q3, and CF we have equals to 37.5. All right, so we have the Q3 that is equals to 17.8 kilometer, and its range is from 17 to 19. All right, so we need to calculate IQR, that is equals to Q3 minus Q1. Okay, so I'm just going to minus 70.8 minus, we have 11, and we got IQR that is equals to, we have 6 and 8 kilometer, and its acceptance between a 5 and 9. That is the required thing that we need to find out in this question. All right, so the next we have a question is 2.4. Okay, the families of four of the athletes above who stay between 15 and 20 kilometer from a suitable training facility decide to move 10 kilometer closer to the facility. In which interval will the number of athlete increases? All right, so we need to find out the number of athletes on which it is increases. All right, so we have the number of athletes is 12, the total number of athletes. Okay, and we have to determine the interval where the number of athletes will increase. So the four athletes originally had a distance, if we say that four athletes, okay, having a distance that we say that its x belongs to 15 and 20. All right, and when they move 10 kilometer closer, okay, move to 10 kilometer closer, okay, so the new distance will be x prime equals to x minus 10. All right, so we must find the new range of the distance x prime, identify the corresponding interval from the table. Okay, so we have to determine the new distance range for the four athletes. Okay, original range, okay, this is, we have to assumption. So original range, that is, we have 15 less or equals to x less than 20, and new range, that is, we say that x prime equals to x minus 10. Okay, So we say that this is equals to 15 minus 10 less or equals to x prime less than 20 minus 10. So we have a 5 less or equals to x prime less than 10. So this is the new distance that falls through into the interval. We have 5 less than x prime, like 5 less than x less than 10 kilometer. The new interval, so the number of athletes will increases in this interval from 7 to 7 plus 4, okay? The number of athletes will increase in this from 7 to 7 plus 4, that is equals to 11. So we have the new interval, that which is we have 5 less or equals to x less than to 10 kilometer, and this is the required thing that we have to find out in this question. Okay, so the next question is about 2.5. Calculate the estimated mean distance that the 50 athletes need to travel after 4 families have moved 10 kilometers closer to the facility. So clearly show all working. So the mean is calculated using the midpoint MI of each class. Okay. So we have the formula of the midpoint, that is, we say that we have x prime equals to summation mi fi by n, and we have the midpoint mi, only the frequency we have is, that is, we have equals to 5 less or equals to x less than 10, and we have the interval changes frequency, and we have 15 less or equals to x less than 20. Interval changes. Okay, so the new frequencies f prime is become, I'm writing over here, the first thing is new frequencies. Okay, so that is f prime. So mostly we have, the first thing we have 15 less or equals to x less than 20, and old we have is f equals to 12, and the new we have f prime equals to 12 minus 4, that is equals to 8. Okay, the second thing we have 5 less than x less than 10. Okay, the old one we have f prime, that is equals to, we have 7, and the new one we have f prime equals to 7 plus 4, that is equals to 11. Okay, the midpoints, the midpoints we have mi, that is equals to 5.7 and 5.12, and we have 5.12, and we have 17, we have a 5.22, we have 5.27, and we have a 5. Okay, so the calculated, we have to calculate summation mi fi prime, that is equals to, we have 2 into 5 into 3. Okay, plus 7 into 5 into 11 plus 12.5 into um, 20 and 17.5 into 8 plus 22.5 into 5 plus 27.5 into 3. Okay? So we need to add them all and we got summation MIFI prime that is equals to 675. And then we need to find out the mean that is x prime. All right, I'm just putting the value x prime equals to summation MIFI prime by n. So we have 675 total and the number we have 50. All right, so the mean estimated mean is we have x prime equals to 13.5 kilometer. And this is the required thing that we need to find out in this question, okay? The next question is question number 3 in the diagram. Below we have an A point. We have an A point. B and C are the vertices of the triangle ABC. AB is produced to SD and F are the x and y intercept of AC respectively. Okay, and F is the midpoint of AC. This is the point where F we have, and the angle of inclination of AC is alpha. Okay, this is the angle of inclination. So the equation of AB is y equals to kx plus 3 and the equation of AC is equals to y equals to 2x minus 2. Okay. So the first question is question number 3 is 3.1. Show that k equals to 1 by 3. Okay, so the given information is that we have the points A, we have the line AB, line AC, and point D, and point F. Okay, so we have to show the k equals to 1 by 3. Okay, let's solve this question. So the vertex A lies on the line of AB, whose equation is we have y equals to kx plus 3. Okay? The vertex A lies on line AB. Okay? And the equation is this. We substitute the coordinate of A into this equation. What is the coordinates of A? A we have is 3 and 4. So I'm just putting the coordinates in this equation. We have the A is 4. We have K and X we have 3 plus 3. I'm just going to simplify the equation. We have 1 equals to 3k and k equals to 1 by 3. That is, we have to prove that in this question. Okay, the required thing is this. So the next question is question 3.2. That is, calculate the coordinate of B, the x intercept of line AS. Okay, so the line AS is the same as line AB. Okay, line AS same as line AB. So which is we have y equals to 1 by 3x plus 3. So the x-intercept is where y equals to 0. All right? The x-intercept where y equals to 0. All right? I'm just putting the y equals to 0 in the above equation. In this equation, we got 0 equals to 1 by 3x plus 3. and we have a minus 3 equals to 1 by 3x, and we have x equals to minus 9. So we say that the B point we have minus 9 and 0. Okay? That is the required thing in question number 3.2. We need to find out. Okay? So move to the next question. That is question number 3.3. Okay? Calculate the coordinates of C. All right. So the line AC has equation y equals to 2x minus 2, and B and C are the vertices of the triangle, okay? So we have to calculate the D. We have to calculate the coordinates of C, okay? So if we say that the line AC is equals EC has the equation, line EC has equation, which is we have y equals to 2x minus 2, okay? And B and C are the vertices of triangle. We must determine how C relates to AB or AC, okay? So the solution, we have to suggest that the coordinate of C are given based on the diagram configurations, okay? Which shows C is the intersection of the vertical line through B and AC, all right? So B is the intercept of AB, okay? And so we have to calculate the F. Okay. So the y-intercept of AC, y-intercept of AC, right? So set x equals to 0 in y equals to 2x minus 2. When you put y equals to 2 into 0 minus 2, we got minus 2. And the F coordinates we have is 0 and minus 2. Okay, from this we have to calculate the coordinate of C. Okay, so we have an F that is equals to x plus 3 by 2 and y plus 4 by 2. All right, so I'm just going to do a simplification. X plus 3 by 2, that is equals to 0, and y plus 4 by 2 equals to 0. So x plus 3 equals to 0 and y plus 4 equals to 0. X equals to minus 3 and y equals to, sorry, we have over here not a 0 because we have over here minus 2, and this 2 becomes 4 minus 4, and this plus 4 over here go to the minus 8, okay? So the coordinate we have, the coordinate of C that we have to determine is minus 3 and minus 8. And this is the required thing that we have to find out in this question, okay? So move towards the next question, that is we have 3.4, okay? In 3.4 question, determine the equation of the line parallel to BC and passing through S. Okay, parallel to BC and passing through S. Write your answer in the equation form. Okay, in this equation form. All right. So we have the gradient of so parallel lines have equal gradients, as you know about that. So first we have to find out the gradient of BC. Gradient of B and C. That is, we need to find out. Okay. So for the gradient of BC, we have to the coordinates of B. That is, we have -9 and 0. And coordinate of C, that is, we have -5 and -12. All right. So how we find out the gradient of BC, that is equals to -12 minus 0 minus 5 into -9, that is equals to -12 by 4, which is equals to -3. So the gradient of parallel lines, that is equals to, we say, m equals to 3. Now the equation through S using, okay, equation through S. What we have? Y minus y1 equals to m into x minus x1. Okay. So y minus into -2 and 3 is m equals to, we have -3. Sorry. -3 into x minus into -15. Okay. So I'm just going to simplify this equation. Y plus 12 equals to -3 minus 45. Okay. And we have a y equals to -3x minus 45 minus 2. And we got the equation, which is we have y equals to -3x minus 47. Okay. And this is the required answer that we need to find out in these questions, because the question requirement is that we have to put the answer in the form of equation. Okay. So the next question is 3.5. Calculate the size of BAC. Okay. So we use the angle of inclination. That is, we have a theta method. Okay. So BAC is alpha minus, we say that BAC. Okay. We say that it is equals to alpha minus beta, where alpha is the inclination of AC. The gradient is 2. All right. Here we say that alpha is in of AC, and where we have a gradient AC equals to 2, and beta is the inclination of AB. Okay, where the gradient A of AB equals to 1 by 3. Okay, so inclination of AC, that is equals to, we have inclination of AC, that is equals to alpha. We have MAC, that is equals to 2. So tan alpha equals to 2. We have alpha equals to tan inverse of 2. And we have alpha equals to 43 degree. Okay. So inclination of AB, 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 that is equals to 1 by 3. So tan beta equals to 1 by 3, that is approximately equals to beta equals to tan inverse of 1 by 3, and we have beta equals to 18.43 degree. Okay. So we have to calculate BAC. Okay. BAC. So in the question we have, all right. So I am just putting over here. We did not have over there. We have a BAC that is equals to alpha minus beta that we have right in the startup. So we have alpha value is 63.43 degree minus 18.43 degree, and we have the angle BAC is equals to 45 degree, and that is the required answer we have to find out in this question. Okay, so move towards the next question. That is, we have, if it is the first 3.6, if it is further given that the length of AC is 6 square root of 5 units, calculate the value of triangle ABD and triangle ASC. All right. So we use the ratio of areas of the triangles. All right. So the ratio of the areas based on the line AS. Okay. The next question is 3.6. If it is further given that the length of AC is 6 square root of 5 units, calculate the value of area of triangle ABD and area of triangle ASC. Okay, so as you know about that, they give the length of AC. Okay, AC, that is, we have 6 square root of 5 units. Okay, so we have to calculate the area of AS. Okay, that is, we have the distance of AS is 3 minus 15 whole square root plus into 4 minus into minus 2 whole square. Okay, and then you have to simplify this equation, this question. We have AS that is equals to 15 minus 3 is equals to 12 minus 12 square plus we have a 6 square, and this is equals to 144 plus 36, and we got over here a 360. So we have a minus 15 over here, and it becomes positive 18. All right, it becomes positive 18, and when you multiply 18 with 18, we got 324. 324. And now we have over here total value is 360, which is becomes in a 6 10. Okay, so AS we have equals to 18.97. All right, now we have to calculate the AB, the distance of AB. In the same way, we have AB, that is, we equals to minus 9 minus 3 whole square, okay, and plus 0 minus 4 whole square, and that is equals to 4 square root of 10. And then we have to calculate AD, that is equals to 3 minus 1 plus 4 minus 0 whole square, that is equals to 2 square root of 5. Okay, now we have to find out the area of triangle A, B, D and triangle ASC, that is equals to 1 by 2 AB and AD sine A, and this is divided by 1 by 2 AS into AC sine A. This is cancelled by each other. I'm just putting the values over here. We have 1 and this 1 by 2 is also cancelled, and we have the value is 4 square root of 10 and 2 square root of 5 divided by we have 6 square root of 10 and we have 6 square root of 5. After solving this, we got 2 by 9. Okay, and this is the required answer that we need to find out in this question. Okay. Now the next question we have is question number 5. In question number 5, we have the first question is from 5.1. If sine 40 degree is equals to P, write each of the following terms of P. Okay. So first of all, we have 5.1.1, that is we have sine 22 degree. Okay. So I'm writing it, this is equals to sine 180 degree plus 40 degree, and that is equals to minus sine 40 degree. Okay, so as they say that we have sine 40 degree equals to P, so I'm writing that we have sine 22 degree equals to minus P. All right, and the next is we have cos square 50 degree. Okay, so I'm writing it like that, 90 degree minus 50 degree. Okay, and then this is equals to sine 40 degree. Okay, and then we have over here cos square, so we're taking the square on both sides, so it becomes sine square 40 degree, that is equals to P square, because sine 40 is equals to P and we have a square on it, so we say that that is equals to P square. All right, so next is 5.1.3. all right, so in this we have using the negative angle identity, that is cos minus theta cos into minus theta equals to cos theta. All right, so and the double angle identity is cos 2 theta is equals to cos 2 theta equals to 1 minus 2 sine square theta. All right, so we have writing cos into minus 80 degree, that is equals to cos 80 degree. All right, so we have I'm writing it like that, cos into 2 4 2 degree and 40 degree. Okay, so I'm writing 1 minus 2 sine square 40. All right, so that is equals to 1 minus 2 p square. So cos minus 80 degrees equals to 1 minus 2p square. All right. Next question is 5.2. Given that tan x into 1 minus cos square x plus cos square x equals to sine x plus cos x into 1 minus sine x cos x by cos x. Okay, so we have two questions in 5.2. 5.21 is that prove the above identity. We have to prove it. And the second question is 5.2.2, for which value of x the interval in the interval of minus 180 degree to 180 degree will be the identity be undefined. Okay, so let's solve the question number 5.2.1 first. Okay, so we have to prove this, okay, that left hand side equals to right hand side. All right, so I'm just taking the left hand side, that is we have we have left hand side, we have tan x into 1 minus cos square x plus cos square x. Okay, so I'm going to write it be like that. This is tan x, and that is equals to, we have sine square x. As you know that sine square x plus cos square x, that is equals to 1, and 1 minus cos square x equals to sine x. Okay, plus cos square x. All right. Now I'm writing this tan x like that, sine x by cos x, and I'm writing a sine square x plus cos square x. Okay, and then we have to write it like that, sine cube x by cos x plus cos square x. All right, so now I'm taking the LCM and writing it be like that. We have LCM of cos x, and I'm writing sine cube x plus cos cube x. All right. And now, as you know about the formula, that is we have AQ plus BQ. All right. That is equals to, we have A minus B and A square plus B square minus AB. All right. So we are apply this formula over there. All right. So we have a sine x plus cos x, and we have sine square x plus cos square x minus sine x cos x, and the whole is divided by cos x. All right. So this is the right hand side, that is we have to find out. Okay. As you can see over there. Okay. So we need just one more step. I'm just writing the one more step over here. That is 1 sine x plus cos x into 1 minus sine x cos x. Okay? And divided by cos x. Okay, this is the right hand side. So what I do, why I write 1 over here? Because as you know about that, the sine square x plus cos square x, that is equals to 1. Okay, I'm just putting this term equals to 1, and this is the right hand side that we have to require. Okay, so we say that left hand side equals to right hand side, that is we have to prove it. Okay, so the next question is 5.2.2. All right, 5.2.2. All right, so over there we have to find out the value of x, that is the interval x belongs to minus 180 to 180. Okay, while will the identify the will the identity be undefined? Okay, so the identity is undefined when any denominator is 0, the term tan x introduce cos x in the denominator, and the right hand side explicitly has cos x in the denominator. So the identity is undefined when cos x equals to 0, and in the interval of x belongs to minus 180 degree to 180 degree, cos x equals to 0 at x equals to minus 90 degree or x equals to 90 degree. All right. So this is the required thing that we need to find out in this question. Okay. So let's move to the next question, which is 5.3. So 5.3 is having expression sine 150 plus cos square x minus 1 by 2. So it has two parts. The first part is the first part we have is 5.3.1. Without using a calculator, simplify the expression given above. We have to simplify this expression and to a single trigonometric term in terms of cos 2x. All right. And the second is that we have to determine the solution of this. All right. So let's solve the 5.3.1. All right. So what we have the expression? The expression is we have sine 150 degree plus cos square x minus 1, and this is divided by 2. All right. So using the reduction formula, sine 150, all right, sine 150, that is we have to write it like that, sine 180 minus 30 degree. Okay, and that is equals to sine 30 degree, and which is equals to 1 by 2. Okay, so I'm writing over here instead of sine 150, can I put 1 by 2? Okay, I solve like that. You are doing this thing, and I'm writing plus cos square x minus 1 by 2. Okay. Now the next step is that we have to substitute the value, and I'm going to simplify this cos square x minus 1 by 2, because we have a 1 by 2 minus 1 by 1, and after solving this we get minus 1 by 2 divided by 2. Okay, now I'm taking 1 by 2 common. Okay, and what we get? We get 1 by 2, sorry, we get 2 cos square x minus 1 divided by 2. All right. So we have 1 by 4 into 2 cos square x minus 1. So as you know about that, this formula that is equals to cos 2x. So I'm writing 1 by 4 cos 2x, this expression. And this is the answer that we have to find out. Okay. So the next question is 5.3.2, where we have a function and we need to equate this function is 1 by 25. Okay. So we have the function that is, I'm writing over here 150 degree plus cos square x minus 1 divided by 2, and we need to prove that is equals to 1 by 25. All right. So I'm writing just 1 by 4 cos 2x that we have to find out, and 1 by 25. All right. So cos 2x that is equals to 4 by 25, and we have find the reference angle alpha, you can say that we have an alpha that is equals to arc cos into 4 by 25. Or you can say that you can find the value like that, okay? Alright, you can write it like that. So the answer of the arc alpha is 80.79 degree, okay? Now, since cos 2x is a positive, we must use the first and fourth coordinate. And in the first coordinate, the case 1, so in the first coordinate, we say that 2x equals to alpha plus k, all right? That is, we say this 360. So 2x, so we have 2x equals to 80.79 degree plus k dot 360, and that is we have 40.40 degree plus k dot 180 degree, okay? And case 2, we have the fourth coordinate, okay? So we have a 2x that is equals to 360 degree minus alpha and plus k dot 360. All right. So I'm just writing 2x equals to 360 degree minus 80.79 degree plus k dot 360 degree. Okay. So we have a 2x equals to 279.21 degree plus k dot 360 degree. So 139.60 degree plus k dot 180 degree. So we have the value of x is this. So this is the required thing where k, we say that k belongs to integers, and this is the required thing that we need to find out in this question. Now we have the question number 6. In the diagram, the graph of f of x equals to cos into x plus a, and we have g of x. We have an f and we have a g function. The f function is equals to cos into x plus a, and the g function is equals to sine 2x, are drawn by for the interval where x belongs to minus 180 degree to 180 degree. The graph intersect at end point. Okay, this is the endpoint, which is minus 75 degree to k, and P is the point over there where is 45 degree and 1, and Q point and P also is a turning point. This is also in the turning point in both graphs, okay? So we have 180 to minus 180 on x-axis, all right? So what do we have to find out in this question? The question number 6.1 is we have write down 6.1, we have write down the period of f, okay? So as you know that the function we have is, I'm writing over there, the f of x that is equal to cos x plus a, and the g of x function that is equals to sine 2x. All right, so 6.1. All right, so the function f of x is this. The period is calculated as, okay, the function of f of x is equals to cos x plus a, and period is calculated as 360 degree by b, okay, where b equals to 1. All right, so I'm just calculating this. We have period f that is equals to 360 degree by 1, and we get the answer is 360 degree. Okay, so the second question is 6.2. Write down the amplitude of G. Okay, now solve the question number 6.2. So the function of g of x is 2x, all right? So the amplitude is the absolute value of the coefficient of sine 2x, all right? The function of g of x, that is, we have sine 2x, and the amplitude is the absolute value of the coefficient of sine 2x, which is, we have amplitude of g that is equals to 1 mod of 1, and the answer is 1. Okay, and the third thing, the next question is 6.3. Okay, so in 6.3 we have to calculate the value of a. All right, so how we find out the value of a? So as you know that we have the p is the turning point of function f of function f of x. All right, so we have to substitute x equals to, this is, we have x plus a. Now we substitute x equals to 45 degree, and we get f of x equals to 1. All right, so I'm just writing it. Substitute in the function, we have f of x equals to 1 and cos 45 plus a. All right, so we have writing this like that general solution for cos theta is equals to 1. So we have a 45 degree plus a equals to 360 degree. All right, so we have a equals to 360 minus 45 degree, and we have to calculate the value of a. So a equals to minus 45 degree. Okay, a equals to minus 45 degree, and when n equals to 0. Okay, this is over here we have an n. All right, and this is the required answer that we have to calculate in this. Okay, so moving to the next question. Which is 6.4. Calculate the value of k, the y coordinate of n and q without the use of the calculator. Okay, so we have to calculate the value of n. Sorry, we have to calculate the value of k. Okay, So you know about that the value of n is the coordinates of n, sorry, we have minus 75 degree and k is on the graph, and the function we have g of x that is equals to sine 2x. Okay, so we substitute the value, put the value x equals to minus 75 degree. So what we get, k equals to g and into minus 75 degree. Okay, so we have k equals to sine into 2 multiplied by minus 75 degree, all right? And this is, we get k equals to sine into minus 150 degree, okay? So k equals to, we have minus into 180, sorry, over here, sine 180 degree minus 30 degree. I'm using the reduction formula, like we have, if we have sine into minus theta, that is equals to minus sine theta, okay? So we have minus sine 30 degree, all right? So the value of sine 30 is equals to 1 by 2, okay? So k equals to minus 1 by 2, and this is the required answer that we have to find out in this question. In this question 6.4, okay? Now, the next question is, we have 6.5. Calculate the value of x if g into x plus 60 degree is equals to f of f into x plus 60, and x belongs to minus 45 degree to 0 degree, okay? So let we say that the theta is equals to x plus, let we say that theta equals to x plus 60 degree, all right? So the equation of g of theta equals to f of theta, which means that theta is an x coordinate of an intersection point. So the original intersection point area, oh sorry, the intersection points are at x intersection, that is equals to minus 75 degree and 165 degree. So, and also x intersection, that is equals to 45 degree, all right? So the turning point P, where f of x equals to g of x equals to 1, turning point. Where f of x equals to g of x equals to 1, all right? Now, set x equals to x plus 60 equals to 45. X plus 60 degree equal to 45 degree. Okay, so I'm writing over here x plus 60 equals to 45 degree, and x equals to 45 degree minus 60 degree, and the answer is minus 15 degree. All right, so we say that minus 15 degree belongs to minus 45 degree to 0 degree. Okay? So this is the required thing that we need to find out in this question 6.5. Okay? So let's move to the question number 6.6. Mm. So in 6.6, without using a calculator, determine the number of solutions. The equation we have square root of 2 sine 2x equals to sine x plus cos x has in the interval x belongs to minus 90 degree to 90 clearly show all the working, okay? So let's start this question. So we have to simplify first of all this equation, the identity they given us. We have a square root of 2 sine 2x that is equals to sine x and cos x, okay? So sine 2x equals to we have 1 by square root of 2 sine x plus 1 by square root of 2 cos x, and when we divided by square root of 2 we got, okay, when we divided this square root of 2 on this side we get this, and now we have the angles, okay? So sine 2x equals to cos 45 degree sine x plus sine 45 degree cos x, okay? So as you know that the special angle is 1 or y square root of 2 equals to sine 45 and cos 45, all right? I'm just putting the values of the angle. So we have a sine 2x that is equals to sine into x plus 45 degree, okay? So now solve the trigonometric equation for case 1, all right? For case 1, we say that 2x equals to x plus 45 degree plus 360 degree n, all right? So we are in x equals to 45 degree plus 360 degree n. For n equals to 0, we have x equals to, for equals to 0, we have x equals to 45 degree in interval. Okay? So for case 2, we have 2x that is equals to 180 degree minus into x plus 45 degree plus 360 n. Okay? 360 degree n. Now I'm solving this. We have 2x equals to 135 degree minus x plus 360 degree n, all right? So we have a 3x equals to 135 degree minus 3 plus 360 degree n, all right? So x equals to 45 degree plus 120 n degree, okay? So for n equals to 0, we have x equals to 45 degree, all right? So if we have for n equals to minus 1, for n equals to -1, then we get x equals to -75 degree. All right. So so we say that the x belongs to -90 to 90 degree. The unique solution are x equals to 45 degree and x equals to -75. So the numbers of solutions, we say that is 2. Okay. And this is the required thing that we have to find out in this question. So the next question is question number 7. The first part of question number 7.1. In the diagram of triangle ABC is drawn. AD is drawn such that AD is perpendicular on B and C. So the 7.1 having some further parts is 7.1.1 and 7.1.2. So let's have a look on 7.1.1. Use the diagram above to determine AD in terms of sine B. Okay. So we have to solve this question, 7.1.1, okay? So use the definition of sine in the right angle triangle, all right? By using the definition of sine in the right angle triangle ABD, okay? So we have sine B that is equals to AD divided by AB, okay? So we have to find out AD. So AD equals to AB into sine B, okay? This is the required answer that we need to find out. So the next is 7.1.2. Hence prove that the area of triangle ABC equals to 1 by 2 BC into AB sine B. Okay, that's very simple question. We have the 7.1.2. All right. So use the standard area formula and substitute in the result of 7.11. Okay. So we have the area of triangle ABC that is equals to half multiply with base multiply with height. Okay, so we have 1 by 2 multiply with BC multiply with AD. Okay, so substitute AD, the value of AD over here, as we find out the value of AD from 7.1.1. So we have answer is 1 by 2 BC, and the value of AD over here above is into AB sine B. Okay, this is the required answer that we need to find out in this question. Okay, let's move to the next question of 7.2. All right. So in 7.2, in the diagram of points B, this is the point B, C and D lie on the same horizontal plane, as you can see over there, the shaded area. So ADB and ACB equals to alpha, all right? So CDB is equals to theta and DC equals to K units. BD is equals to BC, all right? So we have to prove that in 7.2, we have 3 subparts of this question, and the 7.21 is that prove that AD equals to AC, and we have to 7.22 is we have prove that BD equals to k by 2 cos theta. And 7.23, we have determine the area of triangle BCD. All right. So I'm just writing over here the solving the first part of this question. That is, we have to prove that AD equals to AC. All right. So what we say 7.2.1. Okay. So we have the angle we have the angles opposite to AD and AC in triangle ADC are equal using the properties of isosceles triangle BDC, and the given angles are. So in the triangle BDC, we say that BD equals to BC, and that thing leads to D2 equals to C1. Angles opposite, we write angles opposite and equal sides. Okay? So the second thing we have is, this is the first point. The second point is we have D2, that is, we say that is equals to 180 degree minus DBC and divided by 2. So the given CDB, that is equals to theta is full of T. Okay. So the third point is that we assuming the diagram notation means ADB and ACB are the full of angles at D and C in the triangle ADC. All right. So we say that C1 and C1 is equals to D2 is equals to C1 equals to D2 equals to theta are the base angles of triangle, are the base angles of triangle BDC. Okay? That is, we have to prove in 7.22. The fourth point is that in triangle ADC, okay, we have D that is equals to ADB. All right. So this thing is equals to alpha, and the C that is equals to ACB that is also equals to alpha. All right. So the next point is 5 point. So since we say that since a D that is equals to C and this thing both are equals to alpha in the main triangle, ADC, okay, the sides opposite are equal, so we write it AD equals to AC. Okay, so this is the required thing that we need to prove in this question. So the next is 7.22, prove that BD is equals to K by cos theta. Okay, we have 7.2.2. Okay, we have a BD equals to K by 2 cos theta. All right, so we have to prove that that is equal to this. All right, so using the cosine rule in the triangle by using the cosine rule in triangle BDC. Assuming the base angles are theta, as we know about that. Assuming base angles are theta. So the first thing is that we have in triangle BDC, where BD equals to BC, okay? And let we say D2 that is equals to C1, which is we say that it is equals to phi, and P1 that is equals to 180 degree minus 2 phi, right? So assume for the proof that the angles opposite DC is 180 minus 2 theta, okay? The second point we have assume for the proof that the angle opposite DC is 180 degree minus 2 theta. And the third point is that so B1 that is we say that equals to 180 degree minus 2 theta. So the fourth point is we have a cosine rule. Okay, we have D square equals to BD square plus BC square minus 2 into BC and BD cos B1. Okay? So I'm just putting the values. We have the value of this K square equals to BD square plus BD square, okay, minus 2BD square in cos into 180 minus 2 theta, okay, 180 degree. So K square equals to 2BD square into 1 plus cos 2 theta, okay? I'm just closing the formula. So using the identity, 1 plus cos 2 theta is equals to 2 cos square theta. We have K square equals to 2BD square into 2 cos square theta, and that is equals to 4BD square cos square theta. That is equals to K square, right? So I'm just going to find out the value of BD. So I'm taking the square root on both sides. So we have the value is BD cos theta, and we have BD that is equals to 2K by 2 cos theta. And this is the required answer that we need to find out, okay? So this is the second question, okay? So now we have to find out the third question is 7.2.3. Determine the area of triangle ABC in terms of K, okay? BCD. BCD. This is the shaded area, okay? And a single trigonometric ratio of theta, right? So now we have 7.2.3, okay? So using the area rule, okay? So we have the formula of area that is equals to half BD dot BC sine B1. Okay. So this is the results from 7.22. And I'm writing over here area of triangle BCD that is equals to 1 by 2 BD square sine into 180 minus 2 theta. Okay, 180 degree minus 2 theta. So now we have to simplify this 1 by 2 into k by, I'm putting the value of BD. We have Ka by 2 cos theta, taking the square root, and sine 2 theta. Okay, so we have 1 by 2 k square 4 cos square theta sine 2 theta. All right, so we have k square by 8 cos square theta and sine 2 theta. Okay, now we have k square by 4, and I'm writing over here, if we open sine 2 theta, that is equals to 2 sine theta cos theta. Okay, if I open this and this 2 cancel this 8, and we get over here cos square theta, and over here we have sine theta cos theta. Okay, we like that. So this cos cancel by this, we have k square by 4, and we have sine theta by cos theta. All right, so we have area of triangle BCD that is equals to k squared by 14 theta. All right, this is the required answer that we have to find out in this question. Draw a diameter. Diameter CF, that is the CF, and draw chord BF. Okay, so the angle, first thing is that we have MCE that is equals to 90 degree, means tangent perpendicular to diameter. Okay, second thing we have is FBC that is equals to 90 degree angles in semicircle. Okay, so the third point is that we have BCE equals to 90 degree minus BCF, and fourth point is we have a triangle FBC BFC equals to 90 degree minus BCF. So sum of all angles of a triangle. Okay, this is the sum of all triangles. Okay, so the next is we have fifth point is that from the 3 and 4 B C E that is equals to BFC. All right. So 6th point is that we have B, this point B, F, C that is equals to C. It is equals to B, A, C angle subtended by the same arc BC. Okay. And 7th point is that we have to look at therefore BCE that is equals to BAC. Okay, this is the thing that we have to grow in this. Alright. So the next is we have 8.2. In 8.2, we have the diagram PQRS is a cyclic quadrilateral with RQ is equals to RS. ST is the tangent to the circle at S. SR is produced to N. R2 is equals to 68 degree. So determine with reason the size of P, Q1 and S. Okay, P, Q1 and S1. So let's prove this. Okay, the next we have 8.2.1. All right. So 8.2.1, we have to find out P. So we use the angle on the straight line and opposite angle of a cyclic quadrilateral. Okay. So the first thing is cube RS equals to R1 that is equals to 180 degree minus 68 degree that is equals to 112. Okay. And the second thing is P plus R1 that is equals to 180 degree opposite angles of cyclic quadrilateral. Okay. So we have to write it P that is equals to 180 degree minus 112 degree that is equals to 68. This is the required thing that we have to find out in 8.2.1. Now the next question is 8.2.2. We have to find out Q. Okay. So find Q2 from the isosceles triangle from iso RS using the cyclic quadratic property with S and finally calculate Q number. Okay. So the first we have in triangle QRS and triangle QRS. Okay. we have RQ equals to RS, RQ equals to RS, which needs to be Q2 equals to Q2 equals to S2. Alright. So we say that Q2 that is equals to 180 minus 80 minus 80 divided by 2, that is equals to 24 degree. Okay. The second point is that we have S1 is the angle between. S1 is the angle between altitude ST. ST and chord R. So we see that S1, so we have to write it like that. S1 is PSR. Okay. Third point we have is PSR. PSR that is equals to S1, S2, and PQR that is equals to 180 minus PSR. PSR, okay? So the fourth point is that we have fourth point in core theorem, which is with they say is T SQ equals to P. Okay, and we say that S1 equals to S1 equals to Q1. So let fifth point we have let RST equals to R2. RST equals to R2 is equals to 68 degree exterior angle of cyclic chord. And the sixth point is that we see that QR and that is equals to 180 minus PSR. PSR, okay, degree. And the seventh point is that we have RST is equals to PQR equals to 68 degree. And the eighth point is that we have using the provided values P and R, PSR that is equals to 180 degree minus PQR. Okay. is 3. And what is that? We have the S3 is RST equals to S1 plus S3. That is equals, you see that RST equals to 180 minus QRS. Okay, we write it like that, equals to 180 minus 112 equals to 68 degrees. Alright, 12 point, we have write it PQR equals to 180 degrees minus P as R. 13 point we have is Q1 equals to 44 degrees. Okay. So this is we have to find out in this question. Okay, so the next part of and 8123 is 8.13 is we have to find out the S1. So using the P-Gyllenhaal theorem by using tangent chord theorem for chord SR have an S plus S3, that is we say equals to PQR. Okay, so S1 is the angle between the tangent ST and chord S. So the angle RST, the angle RST is PQR. So PQR equals to Q1 plus Q2. This equals to 44 degree plus 34 degree, that is equals to 78 degree. So the angle S1 is P. Okay. So the angle RST is PQR. RST is 78. So angle S1 in the diagram O is PSR. Okay. So we say that S1 equals to 78 degree. That is the required answer of this question. Alright. Now, the next question is question number 9. In the diagram of AB is the diameter of the circle with the center F. This is we have an F. AB and CD intersect at G. FD and FC are drawn. BA bisects CAD is equals to D1 equals to 37 degree. So first of all, we have to find out the 9.1. Determine the given reasons. Any three other angles equals to D1. Okay. And the second, we have to show that in 9.2, DG equals to GC. This DG we have to prove that this is equals to GC, and if it is further given that the radius of the circle is 20 units, calculate the length of BG. Okay, so first of all we have to solve 9.1. Okay, so we have used the angles subtended by the same arc and the angle bisector property. So the first point we have to make that A1 equals to D1. That is equals to 37 degree. So angle subtended by the arc BC. Second point is that A2 equals to A1, that is equals to 37 degree. So this is given BA bisects CAD, okay? BA bisects CAD. This is the given thing. The third point we have to make is that B1 equals to A2, that is also equals to 37 degree angle subtended by the arc DC. Over here, the arc BC, and over here, the arc DC. So A1 equals to 37 degree, A2 also equals to 37 degree, and A3 also equals to 37 degree. That is the required thing that we have to find out in this question. So the next question is 9.2. Okay. So we have to prove DG equals to GC. DG equals to GC, right? So we have to prove that triangle D GC is isosceles by showing that D1 equals to C1. All right, so the first point we have to make C1 is equals to A2, angle subtended by the arc DB, okay? Angle subtended by this arc. So from 9.1, we have to make that A2 equals to 37 degree. So we say that C1 equals to 37 degree. So third point, it is given that D1 equals to 37 degree. So the fourth point is that in triangle DGC, okay, we have D1 equals to C1, that is equals to 37 degree. So DG equals to GC. Sides opposite equal angles in triangle DGC. This is the required thing that we have to find out in this question, okay? So let's move to question number 9.3. Okay, in 9.3 we have to calculate the length of BG, and the radius is given, that is 2R20. Okay, so we use the sine rule in triangle by using the sine rule in triangle FBG, okay, and FB, that is equals to 20. Okay, so the first point we have to make in triangle DGC, we have D1 that is equals to C1, that is equals to 37 degree. Okay, so from the triangle BGF, the second point BGF, that is equals to 180 degree minus DGC, okay? And we say that 180 minus 160, that is equals to 74 degree, right? And in third point, we have in a triangle, FBG, B1 equals to 37 degree. That is, we have a radius FB is equals to 20. So the fourth point is that GFB equals to 180 degree minus 74 degree minus 37 degree. That is equals to 69 degrees. Sum of angles in the triangle. So apply the sine rule. Sine rule. We have BG that is divided by sine GFB that is equals to FB by sine BGF. Okay, so BG that is equals to FB sine 69 divided by sine 74 degree. Okay, so we have a BG that is equals to 20 sine 69 degree divided by sine 74 degree. So BG, after solving this, we have BG that is equals to 19.43 units. Okay, that is the required answer we have to find out in this question. Okay. Last question is question number 10. In the diagram of COD is the diameter of the circle with center O. This is the center O. EA is the tangent to the circle at F. EA is tangent at F of the circle. AO perpendicular to CE diameter COD produce intersect the tangent to the circle at E. OB produce intersects the tangent to the circle at A. CF intersects OB in T. CB, BD, OF, and PFD are drawn. Okay. So this is the statement of the question number 10, and this is the diagram. We have over here a triangle C, E, F, C, B, D, and a lot of triangles we can make out in this. Okay. So we have some proofs and with reasons. So the question number 10.1 is that TODF. TOD and F. Like this is, we have a quadrilateral, all right? So it's a cyclic quadrilateral. Okay, we have to prove this and with reason. So let's prove it with reason. 10.1. So we have to prove that the sum of opposite angles is 180 degrees. So OD equals to OF. OD equals to OF, that is equals to R. Okay. So O, this is the given that AO is perpendicular to CE. So O3 is at 90 degree. So we say that O in TODF is, the first point we say that O in TODF is DOF, the, okay, and F is DFT. F is DFT. Okay, so ODF equals to OFD. All right, so radii OD is equals to OF. OD equals to OF. Okay, so we have to assume what the point is we have to make. Second point, we have to assume that TDF that is equals to plus TOF equals to 180 degree. Okay, so we have to write it that we need to T1 equals to T3, okay? And the exterior angles, the interior angles. So T3 equals to P2. Third point is that now if we say that the T1 equals to T3, okay? If angle subtended by the chord DF, T1 equals to T3, and that is we have to say no, and we have to prove that. So we have to, using the angles subtended by DF, we need T1 as equals to T3. We need T1 equals to D3, all right? So we say that the D3 equals to D3 equals to B2, all right? Angle subtended by the arc CAC. So T1 is CTB, T1 is CTB, and T1 equals to A1, all right? And we have to use the property that OFT equals to ODT, that is equals to 180. So final conclusion based on the typical solution structure. So it is likely that DOF that is equals to T1 plus T2 plus T3. Okay, so the intended proof is to show DTF plus DOF are supplementary. So we can say that TODF is a cyclic quadrant exterior angles. AOF is equals to FTD. Okay, so this is the required thing that we have to prove for this. So next is we have a 10.2. Okay, we have to prove that D3 is equals to T1. D3 equals to T1. So using the angle subtended by the same arc, the first point is that D3 is equals to B2. Angle subtended by the arc AC. The second point is T1 and B2 are not directly related, are not directly related. And the third point is that T1 equals to B2, angle subtended by the arc AC, and using A and C on the circle, D3 is subtended by AC, so B2 subtended by arc AC, all right? We say that D3 and B2 subtended by arc AC, okay? So we can say that D3 equals to B2, okay? So angle subtended by the arc, assuming that assuming T1 is ATC and T1 is CTO, okay? So we can say that the T1 equals to D3, all right? So the exterior of side angle of the cyclic quadrant TCB, all right? So the next question is about 10.3. 10.3. We have to prove that del TFO parallel to del DFE, okay? So we have to find two pair of equal angles, okay? The method we have used that find two pairs of equal angles. So the first thing we have TOF and DFE. The second point we have to make is that FTO equals to FD Okay, we say no about these 2 points. Okay, so the angle pair 1, angle pair 1, common angles, we call it common angles. Okay, so we say that this is the third point, TOF, that is, and DEF. Okay, so this is, we also say no. And the angle pair 2, angle pair 2, we have if, the fourth point, if DB parallels to EA, okay, from the 10.4, we say that E equals to D3, corresponding angles, all right? So the fifth point is that D3 equals to B2. So we say that E equals to B2, okay? So using the result of 10.4, we say that the sixth point is TOF and DEF. Okay? So similarity conclusions is that triangle TFO parallel to triangle DFE. Okay? So this is the required thing that we have to prove in this question. So let's move to the next questions, that is about 10.4. We have to prove that if B2 is equals to E, we have to prove that BD parallel to EA. Okay? If we say that B2 is equals to E, then we have to prove that DB equals to EA. Not equals to, we say that parallel. We have to say this is parallel. Okay, so the method we are using the relationship between P2 and the angle subtended by the same arc. So we have to make the point 1, that is P2 equals to E, and that is given thing, okay? And the second point we have to make B2, that is equals to D3, angle subtended by the arc AC. The third point is D3, that is equals to E, transitivity, okay? And the fourth point is D3 and E are the alternate interior angles, okay? So the corresponding angles are, they are the angles formed by the transversal DE cutting lines DB and EA. So we say that DB is parallel to EA alternate angles D3 equals to E are equal. Okay, this is the required thing that we have to prove in this question. Okay, so the next question is that prove that 10.5, we have to prove that DO equals to TO dot FE by AB. Okay, so use the similarity from 10.3 and the radius properties. We say that the first point is from triangle TFO, that is parallel triangle DFE. So we say that TO by DE, that is equals to FO by FE. Okay, and you can write it like that: TO FE equals to FO dot DE. So the second point is that FO equals to DO equals to R, and AB that is equals to 2R equals to 2DO, the diameters. Okay, so third point is substitute FO equals to DO. So we have a DO dot DE that is equals to TO FE. Okay, so the fourth point is that the required proof is we have a DO equals to TOFE by D. So substitute AB equals to 2DO. So DO equals to 2TO dot FE by 2DO. Now we have 2D or square equals to 3OFE. So this contradicts the similarity result DO dot D equals to TOFE unless we have DE equals to 2DO equals to AB. So in assuming the questions meant we have a DO that is equals to DE, which is equals to TO by FE. Okay, so we say that DO equals to TO dot FE by DE, and this is the required answer that we have to find out in this question. Thank you.